Thank you. Okay. Okay. Okay, Ray, we want to get started here. Okay, guys? These are the different forms of equations for parabolas. Okay, Cole, do you remember this? You're going to be changing from form to form. So we just have to recognize these. You have notes. You may use notes. Okay, Ray? Remember, this is general form. First one. The second one is when it's factored. We can go from general to factoring. We can multiply this out with FOIL and go back to general. But what about this vertex form? That's the only thing that I'm a little bit worried about because that makes it a little bit harder. It's week and a half. Right. Yes, but you're going to miss the lesson. Okay, you guys. Now, where's the vertex here? The vertex is at, okay, guys, what you want to do, David, is make this value 0. What x value would make that 0? If x is equal to what? Now, 0 minus h is still not 0. What if you just put in h? What's h take away h? No. I gave you an h to take it back. How much? Nothing. So you want h. So you look at the number that would make that 0. So if it's x minus 4, it would be 4. And then you just take the k value. So they're handled differently. I could actually put this in a form like point slope form, which would look like this. Y minus k is equal to x minus h squared. Do you remember point slope form for lines? Y minus y1 equals the slope x minus x1. Very similar. And that's the reason why, one reason why I like that. It's one reason why I like that form. Okay, so let's see what we're going to do with these problems. First thing is we're going to find, no, you can. That's good. I'm sorry. Just tell me if I go too fast. This is a line right here, and this is a parabola. How do I know it's a parabola? By looking at it, because it has an x squared term, and this has an x to the first power. That's how I know. But it looks similar. Now, the way this is being presented, my vertex form is going to look like this. Either way is okay. And actually, there's reasons for why I might want to even change this to look like my vertex form. Now, are we ready? Okay. Now, you're going to have 5 points that you're going to be looking at when you graph a parabola. 5 key points. One of them is the y-intercept. So there's 5 key points. So the first one is the y-intercept. Remember what that is? Do you remember what the y-intercept is? This is the y-intercept. Do you remember that? That's 1 point. And the y-intercept, what's true about the x-coordinate? Cole? What's true about the x-coordinate, the y-intercept? Yeah, it's 0. Okay, so if you want to find the y-intercept here in this problem, you would substitute in x equals to 0. And what do you get? Suzanne? You have notes there. You don't need your iPad. So what do you get? Y equals what? What x is 0? 0 squared. 5 times 0 minus 8. What are these guys going to give you? That's right. That's 0. What's 0 take away 8? That's right. So what's the y-intercept? It's at 0, negative 8. Sorry, my 8 doesn't look very good. Okay today?
I'm so good.
Yeah, put that away. Okay, what's this one going to be? Henry? X is going to be 0. What's y going to be?
Y is going to be a number.
Yeah, but in this particular equation.
There you go.
Cole, can you help him? Why not? Well, I'm going to put 0 right in here. What do you get, David?
Okay, are we supposed to be running?
Yeah.
0.
We're finding the y-intercepts.
0. 0.
What's 0?
X2 is 0.
X is 0. So that's 0 squared minus 2 times
0.
0. What's any number times 0?
0.
You just did 0 product property, right? Plus 5. David, you're not going to know how to do this. Okay, so what's y equal to? What happens to all of this stuff?
Take it out.
It's gone. It's 0. Okay, so it's 0, comma.
Do you have any tests or quiz coming up in this class?
Yes, we'll have something next Wednesday. I may not be finished with everything, so I'll see where we're at.
When's our next day?
Next Wednesday. A week from tomorrow is our last day before spring break. It's our last summative assessment as well. What's wrong? I have those too. Cole, do you have that done?
Yeah.
Good. I'm still waiting. Now, do I care if you substitute in the 0 here? No. Kate, Ray, I don't care if you show me the zeros there. This is the y-intercept. No, it's not 2.0, it's 2 times 0. That is a times sign. If it were 2.0, it would be like this. This is 2 times 0. It's because that's the way somebody defined it ages ago. I could have done parentheses. But parentheses aren't always true. Do you remember f of x notation? Now you think that f times x. Does this mean multiply? If I do f of 2? No. It has 2 meanings as well. It's a problem. Multiplication's always been a problem. Okay, Ray, are you ready to go on to the next one? Okay. This is the lesson. We're going to graph equations in vertex form. So now we're going to find the 5 main points of a parabola. I don't like that one particularly. But where's the vertex here? What if x is equal to 0? What's y equal to?
0.
0. Okay. Is that an x-intercept, y-intercept, or both?
I'm behind.
Is that an x-intercept, a y-intercept, or both?
That's 0. That's both.
It's both. Now, do you remember the quick way to graph a parabola if this number here is 1?
Oh, yeah.
You count over 1 and you go up 1. Both sides of it, because this is the axis of symmetry. Then we're going to count over 1 and then how many up?
2.
No, odd numbers. 3, but that's a good guess.
Get this stuck in my
1, 2, 3. No, that's a very good guess. Then guess what I'm going to do this one? I'm going to go over 1, up how many? 5. 1, 2, 3, 4, 5. And then I'm just going to reflect that over this axis. These are the same. So these are 2 over. They're the same. They have the same height. And these have the same height. And there it is. There's my parabola. I don't like this one in particular because it's hard to get points other than the pattern that I just showed. The pattern goes as x increases by 1. Sorry, I don't like the way I wrote that. And x increases by 1, the y increases by odd numbers. Okay? That's the simple way. Now, if I have a 2 in front of that, that's going to change everything. You should have a beautiful parabola. It shouldn't be a V. Some people like to do V's. Okay, are we ready for me to change? Okay, here's a vertex. So, where is the vertex going to be? Remember, we want to make this 0. So what x value would make that 0? Just by looking at it. What do you add to 2 to get 0? What? -2. So my x value is -2. And then to do the y value, you take this whole thing, which is what? 3.
-3.
No, it's just 5.
Nope, it's -3. He's right.
How?
This one is exactly what you see written here. This is the opposite of that one. So what I do is I tell you, for the x's, look to see what will make that 0, and then just take that number. So let's graph that. That may be tricky for you. 1, 2, 1, 2, 3. Well, can we find some more points? That's my axis of symmetry. Remember that? So if I go over 1, Cole, how many am I going to go up?
2, 1.
No, 1. Odd numbers. So it's going to go 1. Then what's the next jump? 3,
5,
5.
7, 8, 24.
Now I'm going to go over 1, 1, 2, 3. Then I'm going to go over 1, 1, 2, 3, 4, 5. And then I'm going to reflect over that. It's like taking the paper and folding it. Where will this point be? It'll be the same space away from that line. And this is going to be over here. And this is going to be how many spaces over? 3. There you go. And there's your parabola. So if I know the vertex and I know the pattern of counting, I can get a picture pretty easily. And there are a lot of things that work like parabolas. How many of you have played Angry Birds? And when I played Angry Birds. The path of the slingshot, we were throwing birds at these guys, right?
Yeah.
It goes like a parabola.
Pigs. 'Cause they
At the
stole
pigs, that's right. 'Cause
Have you played Angry Birds in Space?
beyond pigs.
mm-mm.
It's different.
Oh, that'd be.
Like different.
It would be different because what this does is actually uses the physics and the math in Angry Birds. And if I had my calculators, we could do an activity on that. Well, we could actually. I just have to get calculators. And that's all you do. So you find your vertex, and then you do this counting. Okay, ready? But so there's one application, Angry Birds. Lots of applications for parabolas. Forces due to gravity are parabolic as well. And in the old science museum, there was a spot. They had a parabola here.
What do you mean the old science museum? Isn't it still science museum?
It was in a different location many years ago. And then on the other side of that floor, that level, they had the other half of the parabola here. You don't know enough about parabolas to know this, but if anybody stands here and whispers, whoever's over at that other point, it's called a focus point, but we don't have to know that, and they'll hear. If you're standing here, you won't hear. And I think that was one of the coolest things about that old science museum. I love to do that. So somebody will go stand on that spot, and I go stand there, and you could talk, because what it does is it reflects off and ends up there. It won't end up over here.
We have that on playgrounds.
I don't know. I haven't seen it anyplace else but the old science museum, and they didn't bring it with them for some reason to the new one. I don't care for the new one that much. Okay, take a good guess at what the x value is going to be here. Remember, I want this to be 0. That's a positive 5, because that makes that 0. And where's this one, Cole?
That is 1.
No?
Negative 1.
Think of that. It's negative 1. Because they're doing opposite things here.
Yeah.
This, we're going to make 0, and then we're going to take that entire number.
So positive 5 down.
Down 1. Does somebody want to come up and fill in the rest of the dots?
Cole wants to. No.
I don't mind.
You want to do it? Come on up. Yeah. The rest of you should be graphing it too. Okay, David? Should be graphing it. Did you graph it? Well, first you got to get the dots. You got to get these dots here.
Yeah.
And then, oh, I see you doing, I'm sorry. My mistake. I thought you were drawing the parabola. That's your dotted line. Good job. Okay, where's your parabola? You're supposed to be drawing a parabola. You're supposed to be drawing a parabola. There he goes. He's working on it. He's working on it. Jake, what do you need? Yeah, but Jake, I'm trying to do a lesson.
What happened to the galaxy?
Did I miss? No, I didn't. Okay, and then we're going to put it all together. One more slide to go.
Mom for $200. Is that your phone?
Okay, looks great. There you go. That's right.
He's got a one little dot.
Okay. What we're doing with these parabolas is we're just taking little pieces at a time. We're just taking little pieces at a time and adding a little more. So if you understand it as we go, you should be okay when we put it all together.
Wait, I gotta draw it now.
Yeah, she does. You can turn the page and try and put it all together if you're there.
I actually thought there was a chair.
You can turn the if you're ready. I'm just waiting. You can turn the page and try doing all together now. Now, this is everything we've done. So we've got a lot of work to do. Oh, this is going to take us a little bit of time. No, we just have to do some work. How do you find the x-intercepts? Lucas? Lucas, wake up. Oh, how do you find the x-intercepts? You said 0 equal to this. What am I going to do to that? I have to change the form. It's in general form. What did we do yesterday with these? We factored it, right?
Do the parentheses.
Yep. You don't want to try to go from this form to vertex form. It's not easy. So how do you get x squared? X times x. Now, what do the signs have to be? Plus and plus. So if I don't know what's going to work for 27, I'm going to write down the factors. 1 times 27. Does 2 go in? 3 times 9. Does that give me 12? Yes. And then this is 9. Now, can we find the zeros? I call them, they're called x-intercepts. They're called zeros. They're called roots. So when will this give you 0? Okay, Cole, when will this give you 0? When x is what? Negative 3, comma 0. We just did all this. And negative 9, comma 0. Because that's what we're going to do. We're going to put it all together. Okay, do you remember how to find the axis of symmetry? Should we maybe try and make a little sketch of this to help? I'll do a freehand sketch. Okay, so we have the intercepts of negative 3, negative 9. So there's negative 3, and there's negative 9. Do you remember where the axis of symmetry is? You said it was halfway. What do you do with these two? Does anybody remember what you have to do to them to find the middle point? You average them. x1 plus x2 over 2. So I'd write that down so that, because you can use that on a test or quiz. And maybe we'll quiz on this soon. I haven't even thought about that. So it's negative 3 plus a negative 9 divided by 2. My 2 looks weird. Oh, 3 plus a negative 9 divided by 2. What's a negative 3 minus 9?
Negative 6.
No? Are you giving me the final answer? Final answer is x equals negative 6. Okay, my line might not be in the greatest place there. Okay, then yesterday, do you remember? Yesterday was the pink sheet. Actually, the last 2 days that we were in class, to find the vertex, you put negative 6 into the equation. And you remember I said don't show the substitution, just do the problem. Now, you could put the negative 6 in here and here, whichever way you'd like, or you could put the negative 6 into the original equation. They're both right. Which way? You want to do both ways? What if I put negative 6 in for x squared? I'm going to square it. What do I get? No, negative 6 squared is 6 times 6.
36.
36. Good. Now, plus, what's 12 times a negative 6? Does anybody know that?
12 times 96.
I know what it is. Positive or negative?
Oh, it's negative.
Negative 72. Plus 27. Okay, that's a lot of work arithmetic-wise. Well, if I add these together, what do? 36 and 27 gives me 63. So negative 72 plus 63 gives me how many? 9. Cool. Math. Let's do it this way. Let's put a negative 6 here and negative 6 there. Then I'm going to get, what's negative 6 plus 3? Can I do that in my head?
No. Yeah.
I can't?
No.
Times a negative 6 plus 9. What's this going to give me? Cole?
That is going to give you a...
No.
No.
Negative 6 plus 3 is negative 3.
That's what I just said. I just said negative.
Sorry, how did you get the minus 6 plus
Because this was our axis of symmetry. We can put it into this form, or we can put it in that form. I'm showing you that the second form, if I did it right, is easier. What's negative 6 plus 9? 3.
Positive 3.
So what is the answer?
6.
What multiply? Negative
Negative
9. Okay, so the vertex is
9.
at x is negative 6, and the y value is negative 9. Now, I got to find the y-intercept. We're adding a little bit in here. I told you, it gets a little harder. Let's look at this form, because that's the easiest form. The y-intercept, when you put x equal to 0 in here and here, what's going to happen to those terms? They're going to die off. That's right, there's 0. So what's the y-intercept? 27. Remember y equals mx plus b? It's this number at the end. So it's 27. 0, comma, 27. Okay, we're almost done. Oh, we did equation in factored form. I just wrote it in the wrong place. So y equals, that's this piece right here. X plus 3, x plus 9. Now the vertex form is going to be harder. Okay, Cole, put your phone away, please.
I'm almost done. Trace.
Yeah, Cole, I'll take it away then.
No.
Okay, put it away, please.
She told you we have it like that.
Okay, here is we're almost done here. The equation in vertex form is y equals x minus the h squared plus k. Now, remember where h and k are? This is h and this is k. I'll get out of the way. This vertex form gives you h and k. I'm going to write it bigger. So I'm going to make negative 6, negative 9. This is the h, and that's the k. Whoops. Ah. Somebody decided to call it x and y. Luckily, they did it alphabetical. So I'm going to color these h and k. That's what you want to put in. Okay, Julian, help me out with this. Y equals x minus, what am I putting in for h? Negative 6. I don't even care if you simplify that. It's not important to me. What's important to me is that you can put the right number in the right place. Squared plus the k value. What's k? No? This is the k. This is h. This is k. So it's negative 9. So there's a lot of pieces to this. If I want it to look nicer, I would then, what happens when I do two negatives? Positive. So you're going to probably want notes on this. Whoops. What's plus a negative 9? I can write that better too. Minus 9. There it is. Okay? We put it all together now. Look at everything we found. The intercepts, axis of symmetry, the vertex, the y-intercept. We have our general form that was given, our factored form, and our vertex form. We're going to be switching back and forth between all those forms. To get the vertex form from the general form is hard. It's beyond what we're going to do in this class. Yes, it's hard. Algebra 2 students, your 2 students, have a tough time with it. Okay, so we have a little worksheet. It's really not that bad. I think you can get it done in the hour if you work.